Okay, we're going to do the trig on this triangle right here. So you put a point here, go up to the x-axis, there's your 90 degree. But the question is, here's theta. How big is that angle? And you have to use this to figure it out. So if they started here and rotated a negative 135, to find out this, if they would have gone all the way, I know that's 180. So I'm going to take 180 and minus the 135. And that tells me that what they have left to go is 45 degrees. So this angle is a 45 degree angle. And then I know 45, 90 is half of a square. So here's what it looks like if I put in the whole square, and then I can make up my own dimensions. I can say the square is 2 by 2 by 2 by 2. But sometimes pieces are negative, and this piece is negative because we're going 2 to the left, and then we're going to go down 2, so that's negative also. And then your hypotenuse, this piece right here, is going to be 2 square roots of 2. And the radius, the hypotenuse, is always positive. So cosine. Cosine wants the base over the radius. It wants the adjacent over the hypotenuse, or x over r. So the x is a negative 2. And the radius, the hypotenuse, is 2 square roots of 2. And I'm going to divide my 2's. 2 on top and a 2 on bottom. They divide out. So I've got a negative 1 over square root of 2. But then you can't leave a radical on the bottom. So I'm going to multiply both the numerator and the denominator by square root of 2. So on top I got a negative square root of 2, and on bottom I got a square root of 4, which is a perfect square, which is just 2. So a negative square root of 2 over 2 is my final answer, and that's going to match up with B. Okay, the secant. Secant, if you remember the SOHCAHTOA, the secant matches up with, here's how I remember, secant matches up with the cosine. So if cosine is adjacent over hypotenuse, I know secant has to be hypotenuse over adjacent, or it's radius over x. So that's what the fraction is before I do anything. Now, radians, this is where we just left off. If you have 11 pi thirds radians, let's figure out how many degrees that is. So 11 pi over 3, I'm going to multiply that. Because pi is on top, I'm going to put pi on bottom. I'm going to divide those out. So that means 180 degrees has to be on top. So if pi's divide out, 3, I'm going to cross divide first. And I know 3 is going to go into 180 60 times. And then all I've got to do is times 60 by 11. Is that 660? So it leaves me with 660 degrees. Okay, now 660 degrees is more than one rotation. So if I start right here, one rotation, one whole circle is 360. So if I take away 360 from 660, that leaves me with 300 left. So now 300, there's 90, 180, 270, 300 stops like right there in quadrant 4. So here is the triangle I'm going to do my trig on. And now I got to figure out how big theta is. How big is that angle? And if I stopped at 300, I know it's got to be 60. Because if I would have gone all the way to the line, that's 360. So if this is 60 and this is 30, I know that's an equilateral triangle. There's my other half. And I could say the radius is 10, 10, say they're all 10. That means this one's 5, and this one is 5 square roots of 3. Okay, the radius is always going to be positive, but let's see if these are positive or negative. This 5 is going to be positive because I'm going to the right, but this 5 squared root of 3 is going to be negative because I'm going down. And then let's remember what they want. They want, on top of the fraction, they want the radius, which is 10. And on bottom, they want the x, which is 5. So that's going to give me just 2 for an answer. Okay, let's look at pi halves, cosine of pi halves. Cosine, I know the fraction for cosine is x over r. So pi halves, I'm going to change to degrees. I'm going to times that by 180 over pi. And I know pi cancels, and 180 divided by 2. That's 90 degrees. Okay, now this one's going to be kind of tricky, because 90 degrees is going to stop right on an axis. So 90 degrees is going to stop right here. So when it stops on one of these axes, I cannot make a triangle. So I still need to figure out what my y piece is, what my x piece is, and what my radius is. Okay, the y piece is the one that goes up and down, and I've got that piece, and I can make up my own size. I can say that piece is 10. The x piece is the one that goes left and right, and there's not one. So I'm going to put 0. And the radius is the same as my y piece, so I'm going to say it's 10. So the cosine wants the x over the r, so it wants the 0 over the 10. 0 divided by 10 is 0. Okay, now let's look at this problem number 10. Cosine of theta. So let's use this dot and let's make a triangle. If you come down and make a triangle right there, I'm going to enlarge this triangle. So this dot right here, they went over 2 and they went up square roots of 5. Cosine, that's x over r. So this is my x piece right here. So it's going to be 2 over r, whatever the r is. The r is this piece. And I can use Pythagorean Theorem to find that piece. If that's a 90 triangle, I can use 2 squared plus square root of 5 squared equals r squared. So 2 squared is a 4. Square root of 5 times square root of 5 is square root of 25, which is just 5. And 4 plus 5 is 9, so 9 is r squared. Undo the square, square root. So r is going to be, I know r's got to be 3. So it's going to be 2 on top, 3 on bottom, 2/3. So if they give you a point, you can use Pythagorean Theorem and find out all 3 sides. Okay, your boss asked you to build a ramp for a loading dock. The height of the loading dock is 4 feet. So this is 4 feet tall. Your boss is very specific that the ramp's got to be built with a 32-degree angle of elevation. Determine the length of the ramp. Okay, they want to know this, the dotted line. And do you have enough information? If you know this angle is 32, so there's a 90-degree triangle that's 4 tall. Can you use trig somehow to find out how long this ramp's got to be? So if this is theta, this piece is going to be my opposite piece. The ramp is actually going to be my hypotenuse, and the road is going to be my adjacent piece. So I'm going to make a fraction using 4 and x. So I'm going to use opposite with hypotenuse, and that trig ratio is sine. So if I use the sine of 32 degrees, the sine is opposite over hypotenuse, so it's 4 over x. Now I can solve for x. So x is on the bottom. That's kind of bad. I need to get it out of there. So instead of divide by x, I'm going to times by x. Times this side by x. So now I got this. I got x times the sine of 32. And that's equal to 4. So now just ditch the sine of 32. So divide by the sine of 32. Divide this by the sine of 32. So x is going to equal whatever, 4. At this point it's calculator. 4 divided by sine of 32. So this ramp is going to be exactly 7.548 feet long. That's how long it must be. Okay, fill in the blanks. This is a geometric, and this is arithmetic. Okay, arithmetic means it's growing by addition. It's linear. So 3 to 27, that jumped up 24 times. So if I kind of keep that pattern going, from 27, but I gotta skip one for it to grow by 24. So this is going to be 41. So each time it must be growing 12. So if I go from here, if I want to fill in all the blanks, every single time it's got to grow by 12. Plus 12, 12 plus 3 is 15. 15 plus 12 is 27. 27 plus 12 is 39. 39 plus 12 is 41. 41 plus 12 has got to be 53. So arithmetic just means it grows by addition. Geometric means it grows by multiplication. So 3 times 3 is going to be 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And then 243 times 3 is going to be 729. Okay. Now, if they ask you for a function, this linear function is not bad. If it's grown by 12 every single time, the model for a linear is y equals mx plus b. M is going to be your rate of change. That's how quick it's growing. So m is going to be 12. B, to find b is whatever the mate of 0 is. So if I go back to 0, so that means instead of adding 12, adding 12, adding 12, I need to go backwards 12. So what's 3 take away 12? And b should be a negative 9. So I think this is the rule. Whatever y is, to find y, so for example, let's try 2. Take 2. 2 is x. You're going to take x and times it by 12. So 12 times 2 is 24. And then 24 take away 9 should give you 15. And it does, so that's the rule. Let's try 3. 3 times 12 is 36. 36 take away 9 is 27. So it works. But now if it's grown by multiplication, this is exponential function. So it's going to be y equals something, some base to the x power. Okay, now your base and your exponent, we've got to find these things. This is going to be my base. It's going to, since I'm timesing by 3 over and over and over again, I think the rule is just going to be y equals 3 to the x. So let's try it. So when I plug in 1 for x, it's asking you to do 3 to the first. If I plug in 2 for x, it's asking you to do 3 squared, which is 9. If I plug in 3 for x, it's asking you to do 3 cubed, which is 27. So times by 3 over and over 3 times. So exponential functions, they grow by multiplication. This is going to be your base. Okay, now we've got fractions for exponents. So if we got 625 to the negative 1/4, okay, your negative fraction means you've got to move it to the bottom. So it's going to be 1 over 625 to the 1/4. Okay, now I'm going to break up 625. So the trick is to break these up to their prime factors. So 625 is going to be, if you divide it by 5, 625 divided by 5, it's going to be 5 and 125. Now I'm going to break up the 125. That's 25 and 5. Break up 25. That's 5 and 5. So I'm going to have 1. Instead of 625, I am going to write that as 5 to the 4th raised to 1/4. And when you have an exponent and you're raising it to another level, you times them. So it's going to be 1 over 5 to the 4 times 1/4. And 4 times the 4th is just 1 over 5 to the 1. So it's just 1/5. So 625 to the negative 1/4 is the same thing as 1/5. Okay, 243 to the 1/5. It's the same thing. Let's bust up this 243. 243 divided by 3 is 81. And 81 is a 9 and a 9. And a 9 is a 3 and a 3 and a 3 and a 3. So 243 is 1, 2, 3, 4, 3 to the 5th raised to 1/5. And when you raise a power to a power, you times them. So it's going to be 3 to the 5th times 1/5. So 5 times 1/5 is the same thing. Your 5s are going to cross cancel. Your answer is just 3. That's the exact same thing as a 3. Can't see if you have g to the 4/7 times g to the 3/7, you're going to add the exponents. When you're timesing them, you just add the exponents. So it's going to be g to the 4/7 add 3/7. So it's going to be g to the 7/7, which is just g to the 1. D, if you got b to the negative 3/5, okay, your negative exponent means you got to move it to the bottom of the fraction. So your first move is take it to the bottom. B to the 3/5. You cannot leave a power as a fraction underneath. So we got to change this exponent to a whole number. So you're going to multiply. It's the exact same thing as having a square root on the bottom. If you have a square root on the bottom, we got to change that to a whole number somehow. So you can never have fractions for exponents. Let's change it to a whole number. Let's multiply the top and the bottom by the same thing. Let's times it by 1. Let's multiply by b to the 2/5 on bottom and b to the 2/5 on top. So b to the 2/5 times 1 is b to the 2/5, but on bottom we chose 2/5 because when you multiply 3/5 to 2/5, it's going to be b to the 3/5 plus 2/5. And so on bottom, that's going to be b to the 5/5, which is just b. But on top, you're going to have b to the 2/5. So our final answer, you got b to the 2/5 over b. just b to the 1. But you don't even need to really write that 1 if you want. Okay, now let's morph them into radicals. So if you have a fraction for an exponent, 6 to the 2/5, that is the exact same thing. Here's your radical. The 6 goes here. The 5, you're taking the 5th root of 6 squared. Or you're taking the 5th root of 36. Okay, the second one, x to the 5/3, that's the same thing as x is there, 5 is there, and 3, so it's a cube root. Now you can even clean this up. It's a cube root, so as long as you have 3 or more, some can come out. So if you've got 5 x's, this cube root's going to cancel 3 of them. So that's the same thing as the cube root of x cubed times x squared, because you got to have 5 x's. So if I break it up into a cube and a square, this cube root's going to kill this cube. So you're going to have x times the cube root of x squared. So 1x makes it out, 2 stay in. Okay, now change from a radical into a power with rational exponents. 79, this is invisible 2, that's a square root, and that's a 1. So this is 79 to the 1/2. And this is going to be x to the 2/3. Okay, one of these is going to be real and one is going to be imaginary. This one is going to be real, and this one is going to be imaginary, because they're asking you what number times itself 4 times is a -4. So what number times itself 4 times is a -4. And no matter what number you choose, if you times the number by itself 4 times, it's always going to be positive. It's impossible to have a negative answer. If you times the number 3 times, so something times something times something, you can end up with a negative. And it's got to be a negative, because a negative times a negative times a negative is going to still give you a negative. But if you do a negative times a negative times a negative times a negative 4 times, your answer is going to be positive. So as long as the amount is odd, you can end up with a negative answer. But if the amount is ever even, you're always going to end up with a positive answer. Okay, that is it. There is a Branson Pratt drop somewhere in this video. That'll be a nice treat for you.
I found it already.
You already found the Branson?
Yeah.
What does it do? Does he like take over and narrate for you?
Yep.
Dude, that's sick. What video?
So, you guys plug into an iPad, do the first 2 pages. Keith, my man, you got the back or the packet? There's enough time to get
So is Wednesday the
a page front and back done. What?
Is Wednesday the 23rd?
23rd.